Hi. So today we're going to be looking at using a pre-baked ROM um, to implement a half adder, a 4-bit adder that is capable of adding two 4-bit numbers with a carry out. Well, actually, it doesn't really have a carry out, but it's capable of adding two 4-bit numbers. That's pretty good. Anyway, the way we're going to implement this is in this Excel spreadsheet, and we convert it into another, we convert it into binary, and this is our 8-bit data payload on each address. So here we have operand 1. This is the highest bit of the address. So this is 4 bits, the first, the higher 4 bits of the address, because we're only using 16 bits of the address. And this is the lower 4 bits of the address. So if we go over here to sum, we get our answer, and then it's converted over here into binary. And we just go cascading along up to 15 on each possible input addition. And in this manner, we do every possible output of these numbers from 0 to 15, aka F in hex. So we do this and we get the output, which is, I should show the math. This one is extending base zeros out just to fill this area here, and we do a des to bin command on here, which gives us this in binary, which is not all that it seems to be, and we'll get into that. But over here we have our op in hex. Whoops, well, that's kind of broken. Whoops, forget you saw that. But if we go over here and we take a look at op1 in hex, all it is it's a decimal to hex conversion. And for the sum, all it is just this position plus this position equals the sum. And this is essentially just, converting to binary whatever we have in this sum column here. And it continues along this way the entire length of this with just filling down. And yeah, that's about it. There's not really much more. So the way that we export this, obviously, is we go ahead and we select all of this binary data, and you would think that would be all that you need, and you could just copy this and paste this into your ROM editor, your programming editor or Notepad++ or what have you, and you would be done. But you would be wrong, because every single one of these numbers, when you export it in this way, has a new line on it. Or rather, it is decoded in ASCII, or rather ANSI, and then it has a new line superimposed upon the end of this point here. So every single one of these zeros has 0110 at the beginning of its actual data payload. That's just ANSI. There's nothing wrong with it. This is a 8-bit ANSI character for this number. So we need what is actually the binary for this. We need this in raw. We don't want this in ANSI. We want it in binary. So I could not figure this out for the life of me how to do this. I'm a hardware guy, not really. This is all rather new to me, not a software guy. And he managed to come up with a script that I will show you here. And it's just a brute force script. One moment. All it does is it probably should have prepared this, huh? It just converts your string of ones and zeros into a binary file in Python and just pumps it into a file for you. And that's it. That's all you need. Let me just pull up custom ROMs. And the Python script is somewhere in here. Please hold. Somewhere in here. There it is. No, it's not really opening in Python because probably my Python implementation's all screwed up. But here it is. Essentially, you just copy and paste your string here and end with your apostrophe. And all it does is it creates a bit string and a bit array. I don't really know Python, but compared to C, I'm finding this to be a lot easier. Because I know some C. I was going to implement this in C, and I was trying to wrap my head around how. And he just came in and he's like, "Oh, you can just do this. This is great. This is awesome. This is all you need, though. You just need your string, and it's gonna dump it into a binary file. Bada bing, bada boom." And then you're done. And you take that file, which is in binary, and you open it up just like I did in the last video, and you flash it. I'll open it up. Let's see if I can get to it. I'll open it up in XGECU Pro. We'll load this thing, and it creates a bin file. I think it actually creates a file, something called file.bin or something ridiculous like that. But I've renamed it, obviously, and here it is. And this is it. And you go ahead and you flash this to your ROM, and that's about it. That's all that you have to do on the software side. Now, over here, we had to go ahead, and we're just copying and pasting from 0 to whatever the implementation is, and incrementing it by 15 times 1 on the operand side. That way it makes sense address-wise too, because obviously we don't want the wrong data payload for the right operand inputs, you know what I mean? Because you need to do it sequentially. So it would be harder to do it in this manner with a large array. We actually started working on an 8-bit adder, and without a way to automatically create the data in Excel, it got out of hand rather quickly, and I think that we stopped at around like 1,400 entries or something like that. That was pretty nasty. But in this way, you can pre-bake anything. This could be, right here, we just have it being a sum, but we don't have to do this in sum. We can do this in division. We could do this in multiplication. This can happen in any different way that we want. We just need to supplement this addition instruction with a multiplication instruction or a division instruction and cascade it along down, and it'll pre-bake those equations for the 4-bit input that we want. So you could implement an adder, a divider, a multiplier, whatever have you, in just a pre-baked ROM form. So if you need like a DAC input and a DAC conversion, you can do a division through a PROM, and you can just do it in that manner. It's very simple. So yeah, I just wanted to share that. I'm going to leave you to the bench, and we'll see the actual implementation in binary form, breadboarded up. Hi, so we're here on the breadboard, and we have our adder all hooked up. And in this manner, the way that I have this hooked up right here, we have the first 5 indications of the data output line. This is an 8-bit PROM, remember, so we have 8 lines of output. And we have the first 8 lines of the address. So if we put in 1 on the address here, move over to the beginning of this next 4-bit chunk here, put another 1 in, we get 2 here. This data outline is formatted in the manner of 1, 2, 4, 8, 16. So if we took this down and popped in 8 plus 8, we get 16 over here. If we added another 1, we get 19. So it works in this manner. We add another 1, we get 20. So, you know, it's a pretty sweet, may have messed up what I thought was going on, but it all works pretty good. It's pretty nice here. And obviously, if we bring everything high, we get, which is correct, which is actually pretty sweet. Yeah, that's about it though. It's just 8 plus 8, 16, plus another 4, plus another 4, plus another 2, plus another 2, plus another 1, plus another 1. There you go. And it's an adder. Very simple. You can use this to pre-bake any sort of math that you need. If you don't need it to be very accurate, you could also implement this on a larger ROM, such as a M27C 322, which is a 16-bit PROM, like I have here, this guy. If you implement it on that, you have 16 bits of output, and I believe you have around 20 address bits that you can work with, so you can use up to like 10 bits of input numbers and 10 bits of lower input numbers, and you can add them together, or you can do all sorts of different multiplication and division on there. The sky's the limit. It's just a nice little thing if you know you need to be doing math. And if you were to offload this into RAM, it would be very, very, very fast. All you need to do is just increment the clock cycle with the held high on the RAM. And this is a 200 nanosecond chip, so it's not fast. It's 500 kilohertz around that. But if you were to dump this into RAM or simply use a faster EPROM chip, there are faster EPROM chips. There are out there in the wild 50, 60, 20 nanosecond EPROMs. It's around 14 megahertz, I think, is the fastest you can really get one of these UV EPROMs. If you went to flash, you know, you're golden. That's pretty quick. But I just wanted to make a video about this. It's nothing really big. But yeah, there you go.